Hello students and welcome to IP Study lecture videos. In this video, we will discuss the very first chapter of grade 6 mathematics, and the name of the chapter is Patterns in Mathematics. Students, let us first of all see what are the different topics that we are going to cover under this chapter. So in this chapter, we will cover the role of patterns in mathematics. The second topic will be number patterns and their visual representation. And the third topic will be how the number patterns are related to each other. And the fourth will be shape pattern and their relationship with the number pattern or number sequence. So students, without wasting our time, let's start with the first topic. The topic is the role of patterns in mathematics. Students, have you ever observed the designs on the curtains, or the design of tiles on the floor, or the designs on the wings of a butterfly? All of them look so amazing, don't they? Yes, students. And what is the reason behind it? The reason is their design follow a pattern. Now the question is, what is a pattern? So a pattern is a repeated or predictable arrangement of numbers, shapes, letters, objects, etc. Students, here we have two examples. One is number pattern and other is shape pattern. Let us see why these two can be considered as a pattern. Do they fit in the definition of pattern? So here we can see we have a predictable arrangement of numbers. We can find out the next number in this pattern, that is 10. And how we are doing it? By adding 2 every time in the previous number. Now, why it is a pattern? The second one, because it also show a repeated arrangement as well as predictable arrangement. Here we can predict the next shape, that is a triangle. So ultimately these two are patterns. Now students, if a pattern follows a rule, that is if its members are defined by a rule of mathematics or a certain rule, like here we can find out the next number, here we can find out the next shape, then these patterns can also be considered as a sequence. So basically a sequence is a special kind of a pattern where the pattern follow a definite rule. Now here we have a definition of member or a term of a sequence or a pattern. What it is? It is each number or a shape of a sequence is called term or member of it. For example, here we have 2, we have 4, 6, 8. All of these are members of the number pattern. Similarly, this triangle, this square, this triangle, this square is also a member of the shape pattern given here. Now student, the question is why we study patterns in mathematics. So we study patterns in mathematics because it helps us to understand the rules or make prediction also. And it helps us to understand the world around us in a better way. Now student, we are going to the next topic, that is exploring number patterns and their visual representation. So now the question is, what is a visual representation? So basically a visual representation means representing a number pattern with the help of a symbol or a drawing or a diagram, etc. And why do we do so? Because it helps us to understand the number pattern easily and predict the members of it. Is it clear to you? Now let's move to the different number patterns that we are going to cover in this topic. So student, there are various number patterns and we will cover some of the famous number patterns that we have in mathematics. Now student, here the first topic is sequence of all ones. It means in this sequence every member or every number is one itself. There is no change in the member every time one comes after the previous one. And to represent it visually, we can use a dot or a circle like this, and the number of dots or a circle represent the member of the sequence. Here one dot represent the first member, the second dot represent the second member, and so on. Isn't it interesting? Yes, students. Let's move to the next topic, and the topic is sequence of counting numbers. We already know what is a counting number, which is also known as a natural numbers. Students, the number 1, 2, 3, 4, 5 and so on, which are used to count objects, are called counting numbers. Students, we can represent these counting numbers in the form of visual representation like this. 1 dot for the first member, that is 1. 2 dots to represent second member, that is 2. You can use a circle also. Similarly, 3 dots for the third member. So this is horizontally aligned. We can use also vertical aligned visual representation for these, like this, like this. So it means every visual representation corresponds to the number sequence given here. Similarly, the next topic is sequence of odd numbers. Students, we already know from our previous classes that what is the difference between an odd number and an even number. So basically, an odd number is a number which is not divisible by 2, whereas an even number is divisible by 2. Let us observe how this number form a pattern. So here, every time 2 is added to get the next member, it starts with 1, then we have 3, which is 1 plus 2 equals to 3. Then we again, if we add 2 to the previous member, we can get the next member. So this is a pattern because there is a predictable arrangement of numbers. Now to represent these odd numbers in the form of visual representation or pictorial representation, we can use this diagram. Like we start with 1 dot for the number 1, then we can add 2 more dots, one on the right and one on the top, to represent the number 3 of the number sequence. And similarly for 5, 7 and 9, we can use this visual representation. Student, now I am giving you one task. You have to identify how an even number is a pattern, how we can represent them visually. You have to find out at your own. Now moving to the triangular numbers. So the triangular numbers are numbers which can be arranged in the form of equilateral triangle. What that is? It is a number, a group of numbers which when arranged in the form of equilateral triangle, they are arranged like this. Now, how we can find out the triangular numbers? So student, to find out the triangular numbers, we can add counting numbers from 1. Like for the first member, we have 1. Then we add 2 to the 1. Then 3 to the previous expression. And every time you get a new triangular number like this. 1 plus 2 is 3, 1 plus 2 plus 3 is equals to 6 and so on. So it means if we add counting numbers, we'll get the triangular numbers, and they are called triangular numbers because each member can be represented in the form of equilateral triangle, where the number of dots used to represent the equilateral triangle is equals to the member it is representing. Clear? Here we can see it like 6 dots are used to represent the member third, which is 6 in this number sequence. Now students, we have already covered various number patterns. Now moving to the next number pattern, that is the sequence of square numbers. How we can find out the square number and what numbers are the part of this? So numbers like 1, 4, 9, 16, 25, 36, 49, etc. are the members of square number sequence. And how we find out this? We found out this by multiplying a number by itself. Like we have a natural number 1, we can multiply 1 with itself. Then we have 2. Then if we multiply 2 with itself, which will give us 4, then this type of number will form a square number sequence. And why they are called square number sequence? Because similar to triangular number sequence, if we arrange this number of dots in the form of visual representation, they can form a square where the side length is equals to the natural number used to multiply to find out the member of the square number sequence. Okay, student, moving to the cube number sequence, which is quite similar to the square number sequence with a slight modification. Here, natural numbers are multiplied with itself 2 times, and the number that we get every time is 1 for the first member, then 8 for the second member, then 27 for the third member. And how we get 27? By multiplying 3 with 3 one time, which will give us 9, and then 9 multiplied with 3, which will give us 27. Similarly, we can find out different numbers of this number sequence. Now, students, to represent this number sequence in the form of visual representation, we can use a small cube for the first member, and then smaller cubes are arranged or stacked together to form a larger cube, where the number of cubes used is equals to the number it is representing for the number sequence of cube numbers. Like here, 8 small cubes are used to form this bigger cube, and 8 is the second member of the number sequence. Similarly, 27, then 64, and then 125. Okay. So the next number sequence is the sequence of Virhanka number or Fibonacci sequence. In this sequence, the numbers has a rule. And what is the rule? The rule is we had to add 2 numbers to get the next member. Like first member is 1. Then 1 has nothing previous to it, so 1 will come again. Then we can add these 2, which will give us 2. 1 plus 1 is 2. Then we can add these 2, which will give us 3. Then we can add these 3 and 2 to get the next member 5. So the rule is you have to add 2 members to get the next member, but these 2 members will be the just previous member to the number that we are wanting to get. Okay, so these numbers, when arranged in the form of visual representation, we can have 2 cases. One is Fibonacci spiral and second is Fibonacci rectangle. Let us understand what is the difference between these 2 visual representation. So Fibonacci spiral uses squares, smaller squares with side length equals to the member it is representing. For example, the smaller square that we are observing here has side length of 1 unit, and if we want to add the next square, it is aligned to the previous square, and the side length of the new square will be 2, and it is attached to the square itself. And every time when a new square is formed, a quarter circle is made out of it to form a spiral like this. So first quarter circle is here, then second is here, then third is here, and similarly, if all the quarter circle are arranged, they form a spiral shaped like figure like this. Now, in the first case of Fibonacci spiral, we used square. The Fibonacci rectangles are quite similar to this, and here is your second task. You have to identify how we are representing them visually. So this is your second task, that how you can identify what is happening in the visual representation of Fibonacci rectangles. Now students, moving to the sequence of powers of 2. So students, now the sequence of powers of 2. In this sequence, the sequence of powers of 2, numbers start from 1, then 2, then 4, then 8, 16, 32 and so on. Now let us see how these numbers are formed. So it starts with 1 and 2 is multiplied with itself every time and each stages. Like start with 1, then 1 is multiplied with 2, so 2. Then 2 is multiplied with 2 again, which is 4. Now 2 is multiplied to the previous expression like this, which you can see over here, so it becomes 8. So every times 2 is multiplied to the previous expression, students. Now to represent this process, we have a special way of writing, like 2 then 5 here will represent that 2 will be multiplied 5 times like this. Okay. Now if you want to find the value that it will give, you can multiply 2 times 2 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. It means this expression represent the value 32 of the powers of 2 sequence. Now students, for the visual representation of patterns of power of 2 or sequence of powers of 2, we use dots. Now we use two different dots or different points to show the difference that is happening at every stages. Like here we have 2 dots, then 4 dots, then 8 dots. So it is showing that how the number of dots is multiplied by 2 at every stages. Like here 2 to 4, so here 2 was already present and another 2 comes here, so it is 4. Now 4 is already present and another 4 comes here. So the difference of the colors show how the pattern is going visually. Now moving to the sequence of powers of 3. Students, here what we have to do is we have to use 3 instead of 2. It is quite similar to the sequence of powers of 2. Instead of 2 we use 3. Now here the first member is 1, then 3 is multiplied to 8, then 3 is multiplied to this expression which becomes 9, then 9 multiplied by 3 is 7. So it is quite similar to the previous number sequence that we have already understood. Now let me explain you the visual representation of powers of 3. So students, here the numbers in this sequence are 1, 3, 9, 27. So we use dots to represent triangles in this form. Here we have 1 dot to represent the first member, then 3 dots are arranged to form a single equilateral triangle, then similar 3 smaller triangles are arranged to form a bigger equilateral triangle. Then with 27 dots, a new equilateral triangle is formed like this. Clear? So students, go through these examples and understand the number patterns in a easy way. Now let me solve one question from this exercise 1.1. So question is, answer the following questions, and the first part is, what is the 8th triangular numbers? Students, do you remember how we get a triangular number? By adding consecutive numbers. So if we have first as 1, then second as 1 plus 2, so it means for 8th triangular number I have to add 8 consecutive numbers like this: 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. Now if we add all these numbers, like 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, then 21, and 21 plus 7 is 28, and then 8, which will give us 36. So 8th triangular number is 36. Now student, the second part is, identify the triangular number represented by the sum of first 12 natural numbers. So basically these are the square numbers. Yes. So we have to find out that what is the sum of first 12 natural numbers. So let us add these numbers: 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 and plus 12. If we add these 12 numbers, what we get? 1 plus 2 up to 8 we have already found it out that this is 36. So here we'll have 36, and then we have 36 plus 9 is 45, then 55, and then 66, and then we have 78. So the 12th member will be, which is the sum of first 12 numbers, will be 78. Clear students? Now if 4th even number is represented with dots, how many dots will be in total? So let's check which will be the 4th member of the even number sequence. So first is 2, then 4, then 6, then 8. So 4th member is 8. It means we need 8 dots to represent the 4th member of even number sequence. Students, similarly you can solve other questions. I will be moving to the next topic, which is investigating patterns in number sequence. Students, we have already understood different number patterns. Now in this topic we'll understand how different number patterns are related to each other through some examples. Here we have 3 to 4 examples in this topic, and let us observe what is happening here. So let's start with the example number 8. Here the question says, what happens when we start adding up odd numbers? So let us see what will happen. So if we'll add odd numbers like 1, then 1 plus 3, then 1 plus 3 plus 5, the number that we are getting every time is a square number. So odd numbers are related to square numbers, and how? If we add the odd numbers, we will get the square numbers, and which will be like this: 1, 4, 9, 16. So the number of members used from the odd numbers will give you the square number that you will get. It means the square number, that is 4 members are used from odd number sequence. So the answer will be 16. Isn't it interesting that 2 number sequence are interrelated to each other in this way? Similarly, the 9th example says, what happens when we start adding counting numbers up to certain numbers and then back down? Let us observe what happens. So in this, if we add 1, then 1 till 2, then 1 again, then 1, 2, 3, then back to 1. If we add like this, we are getting again square numbers. Yes, student, we are getting square numbers. So counting numbers are also related to square numbers in this way. So here with these 2 examples, we can understand that different number patterns or sequence can be interrelated to each other with a different rule or different formation, and you can observe all these examples given here to understand it in a better way. Students, let us solve one question from the exercise 1.2. Let us read the question first. Can you find a visual representation for adding counting numbers up and down, which we have already covered in the example? Arrange the dot for each sequence in the same place so that the entire element form a square. So they ask us to represent these counting numbers which are added together from starting and up to in the form of up and down like this, which is 1, 1 plus 2, then plus 1 again, then 1 plus 2 plus 3, plus 2 plus 1 again. We will observe that we'll get a square number every time, and if we try to visualize it, it will look like this: 1, then 4 will be in the form of square like this, then for 9 we have 3 rows and 3 columns, and dot will be arranged like this. Okay, so they were wanting to represent the sum in the form of visual representation. Now similarly you can solve other questions also. Now moving to the next topic, shape patterns and their relationship with the numbers. Let us understand how different shape patterns show a relationship with the different number sequence. So first of all, here we have sequence of line. Here lines are made using points, and the number of points or dot used are like this: 1 dot, there is no line, then we have 2 dot, then we have 1 line, for 3 dot we have 2 line. So number of dots and the number of lines increases with each member, and the number of dot increases by 1 every time, and the number of lines connected to the dots or points also increases by 1. Sequence of stacked triangle, the next shape sequence that we have to observe. Here what happen is, start with 1, which is an equilateral triangle, and with each member a bigger equilateral triangle is made from smaller equilateral triangles stacked together like this, and these stacked triangle form a bigger equilateral triangle, and the number of smaller triangle correspond to the number sequence 1, 4, 9, 16, 25. Students, can you tell me which number sequence are these number of triangles corresponds to? Yes, these are square numbers. So shape patterns also show a relationship with the number pattern that we are studying in this topic. Now next is sequence of stacked square. So students, it is quite similar to stacked triangles, but here the numbers that are used here are 1, 4, 9, and why it is called a stacked square? Because it starts with a single square, and then for the next member we have smaller square arranged in such a way that they form a bigger square, where the number of smaller square correspond to a number sequence 1, 4, 9, 16, 25. Here we have 25 small squares. So students, again, these number sequence corresponds to square numbers. So stacked squares show a relationship with the square number sequence. Isn't it interesting? Yes. Now the next sequence is sequence of regular polygons. First of all, what is a polygon? So a polygon is a figure made up of only line segment, and it must be a closed figure. So the smallest or the first polygon is a triangle, which is made up of 3 sides. Then we have 4-sided polygon, quadrilateral. All of these figures you have already understood in the lower classes. Okay, pentagon has 5 sides, hexagon has 6 sides, and octagon has 8 sides. Now if the number of sides, that is 3, 4, 5, becomes equal to each other, it means all the sides are equal, then these are called regular polygon, and they have some special name for some polygons. Like for triangle, if the 3 sides are equal, they are called equilateral triangle. Then we have quadrilateral as a square, pentagon as a regular pentagon, then hexagon as a regular hexagon. For each type of polygon, we have a special polygon where the number of sides are equal to each other. Not only sides, angles are also equal. Now students, we have the next shape sequence, the sequence of complete graphs. In this, dots or nodes are connected with the help of edge, and every node is connected to the other nodes with the help of a single edge, like this. This node is connected to other two with the help of this edge and this edge. And similarly, we have 4 nodes here, and we have 6 edges connected with each and every nodes. And the name of each member depends on the number of nodes used. For example, here we have 2 nodes or dots. Here the dots are called nodes. So we have K2, K3 for 3 nodes based complete graph, and the number of nodes and the number of edges have a formula, because for 2 nodes we have 1 edge, for 3 nodes we have 3 edges, and for 4 nodes we have 6 edges. So here we have a formula that is been asked here, that is the number of edges will be n minus 1 by 2, where n is the number of nodes used in the complete graph. Students, moving to the next shape sequence, coach snowflake. So this is a shape sequence which is a fractal. And what is a fractal? A shape that repeats itself again and again. So coach snowflake is also known as coach curve. Let's see what happens in a coach snowflake shape sequence. So it starts with an equilateral triangle with 3 sides or 3 edges. Now each edges get a new set of 3 new triangles, like this. This was a single edge. Now here one smaller triangle is coming out, and it is making 3 smaller triangles at the edge. So the number of edges for the new is 4 times than the previous one. Similarly, each edge of this will get a new set of 3 smaller equilateral triangles, and the number of edges will be 48. Then 192, it means 4 is multiplied every time to get the new number of edges. So here we have 48, then 192 edges. So students, this is all from this video. I hope you have enjoyed the video and learned the concept easily. See you soon in the next video. Keep practicing, keep learning.